system characteristic of distribution system. So we are going to cover various characteristic of distribution system. This include reliability, scalability, maintainability, availability, and consistency. So as far in reliability is like what is difference between fault versus failure, and scalability come the loads and some example and measurement of performance, and horizontal scaling and the vertical scaling, maintainability, availability, and consistency, and the cap theorem. So we are going to be various theorem. This is very important topics to understand about distribution systems. So these are this vertical scaling, horizontal scaling, we are increasing number of nodes. Vertical increasing, we are scaling the number of disk, number of RAMs or disk in one same system, CPU or something. And cap theorem, it's comes of consistency, availability, and partition tolerance. So let's talk about reliability. So whenever we deal with distribution system, there is a 5 characteristics particular such a system that we must aware of the understand. So the first one is reliability. Reliability is a system ability to continue to work correctly in splits in the fault. A distribution system is usually made of several smaller subcomponents that together work to deliver service. A reliable system can be backed upon the continue to work without degradation of service. So reliable means it continue to work, it should not stop. So the reliability concept can be extended to include system ability to continue to perform with the expected functionality, tolerance, human error, and unexpected use of system, maintain the performance under high data volumes load, prevent any unauthorized use, and abuse systems when the failure do happen. Now inside a reliables, then what is the difference between fault and failure? So as name suggests, fault means if anything happened but system automatically recover. Failure means whole system is failure, you cannot able to access. So fault means you are still able to access. So let's understand the terms of fault and failure are often used interchangeably but mean the different things. When a part of system experiences failure but the system as a whole can still continue to operate reliable, we label as the system fault tolerance or resilient. The system can be tolerant, component, and deviating from the specs but still function correctly. A failure occurs when the system as a whole fails. No system can be made fault tolerance from type of possible fault can be always potentially fail as a whole. Netflix Chaos Smoky is the example of tool designed to test a resiliency service in the Netflix ecosystem. The tool randomly terminates service instance and uncovers service failure. So this is just example. Now the scalability system said to scalable if they continue to work correctly as a load of system increase. So when we talk about scalability, we talk about load. So what is load? Load can be measured by variety of metrics, including number of requests per second received by the web service, or number of reads from versus number of writes to cache, or frequently of the data backup, number of supported concurrent user, or more. When considering the scalability, we generally question if the system can continue to perform well when one of the parameter increase. So there are some example. You see, let's look to some well-known product. An example of that load parameter, Microsoft Word. As you see, number of geographically distributed user who can correctly modify a document in collaboration mode without affecting the usability of each user. And Facebook, number of users able to view the live broadcast from say. So it's scalable, right? It can watch 1 million, 2 million same time, similar to Google file system or Twitter.
Here's a tasty treat for traders.
And let's talk about measurement performance. When the load parameter is increased, scalable system expected to keep expecting the performance. Amazon S3 service level agreement, which we call SLA, for example, promise certain performance benchmark to user. For instance, Customer are entitled service credited if S3 monthly uptime is its use load is high, so they automatically increase. So let's talk about what is the horizontal versus vertical scaling. So one of load start with increase on the system. It may necessary to re-architect system to handle the new load. There are generally two way to scale up of system. Vertical scaling is add more expensive and briefer machines, or one of which current runs. Considering MySQL servers run on slowly and the concurrent machine, we replace with a new machine with the 10 times memory and computing power than current one. Database service will be able to process much larger number of queries. So this one is has a limitation. Vertical scaling in terms of the distribution system, you mostly use horizontal scaling. Horizontal scaling refer to distributors load across the several smaller machine. There are scaling and vertical scaling as machine can only become powerful before they run into limits of physics. This assuming you don't hit the budget limits of your company into first place. Scaling horizontal brings complexity with this. Yeah. So in the practice, hypothetical approach usually select the address scaling issue, which uses more powerful machine that also spreads load horizontally. Not there is no one size for architecture distribution application operating is scalable. Each application can be have a unique load parameter. Access parameter may be different. So to go SLA response and requirement. And now let's talk about maintainability. One of the components of good software design is a maintainability. There is a three major aspect of maintainability. Ongoing operation. Software should be simple for operator work and provide support for developer who are working on the code base should easily able to grasp the logic functionality in the software. And extensibility, software should be easily extensible to address the new related use cases. So this is maintainability. Basically it's like you should able to do faster. And availability means system should be available for 24 by 7. Availability is another characteristic of distribution system. So the availability is qualified mathematically. We can for our purpose think availability as a length of time system response functionality within a specific period of time. We will say system is 100% available if system is always responsive and functional intent to within a given period of time. So the for distribution system, at least two of the characteristics should work. So this is called the CAP theorem. So first one is consistency, availability, and partition tolerance. So web server example, if you design a service, always return the latest data from the database. The service will not always available for database is down, but it will be still considered a consistent. In distribution system, there is generally several instances of server client of the system, generally talking only one such instance. In that context, consistency implies that client receive the same response from any one of the instance that is sent to the request. Cap consistency, availability, and partition. The theorem capture the relationship between consistency and availability. Thus, the crux of this theorem say that network failure among the different component of the distribution system can't be ruled out, and under such a scenario the system can choose to be either available all time or cost servicing inconsistent data. Always serve the consistent data to the customer to risk of losing availability. So always should be consistent data. We explore each of the part of theorem. Yeah, so as I said in my previous example, yeah, so this is cap theorem. Either one of the should work: consistency or availability, availability or partition tolerance, or consistency or partition tolerance. So this is theory lecture, and next lecture also we are going theory, and after that we will do practical. Please like and subscribe my channel. Thank you for watching.